In this video, we're going to be looking at how to write neutralisation reactions. Remember, a neutralisation reaction is an acid plus a base gives salt plus water. Now, acids contain lots and lots of hydrogen ions, and this gives them a very low pH. Bases contain lots and lots of hydroxide ions, and this gives them a high pH. When you mix an acid and a base together, you are neutralising. So the hydrogen ions combine with the hydroxide ions and they make water. So we need to be able to write acid-base reactions. So the first thing is an acid plus a base always gives salt plus water. So if you've got hydrochloric acid with sodium hydroxide, the easiest thing to find is always the water. And whatever's left over makes the salt. So if we had hydrochloric and sodium hydroxide, the hydroxides and the hydrogen ions and the hydroxide ions make the water, and the salt is made from the sodium ions and the chloride ions. So in this particular case, the salt will be sodium chloride. Remember, you must obey normal ionic naming procedures, which means the metal ion is named before the non-metal ion. So it's sodium chloride. Let's look at the next example. Sulfuric acid plus potassium hydroxide will give us salt plus water. Water, once again, is the easy thing to find. Sulfuric acid contains hydrogen ions and potassium hydroxide contains hydroxide ions. Remember, the sulfuric acid gives two hydrogen ions and a sulfate ion, and the potassium hydroxide would give a potassium ion and a hydroxide ion. The hydroxide and the hydrogens make our water. The remaining part is our salt, which is the potassium ions and the sulfate ions. We must go through normal ionic compound naming procedures. So it's potassium, sulfate. Now let's look at writing balanced chemical equations. So the first part is we're going to write the formulas for hydrochloric acid, which is HCl. Now, because it's an acid, it is aqueous. We've also got the formula for sodium hydroxide, and we've been told it's in solution, so it's aqueous. Now, remember, it gives us salt plus water. Now, the hydrogen ions and the hydroxide ions make your water, plus water. Write the correct formula. The sodium ions and the chloride ions make the salt. Remember, correct ionic naming procedure. Sodium, because it's the metal ion, and then the chloride ions. So it's sodium chloride. And remember, its formula is determined by valence. Now, in order to work out state symbols, we have to go to our solubility tables. So we check out sodium chloride and we go to chlorides. It says most chlorides are soluble in water except for silver chloride and lead chloride, and that doesn't apply to sodium chloride, so it must be aqueous, and water is a liquid. Now, sometimes you're going to be asked to do observations. So you would go and check out your coloured compounds. Now, we have no solids in this particular case, and we can see here that sodium ions are not present on this table. So that means in solution, they make a colourless solution. And if they were a solid, they'd be a white solid. So if we're going to do an observation for this, you would have a colourless solution here. You would have a colourless solution here. This would give us a colourless solution, and water is a colourless liquid. So in this particular case, because everything's still colourless, you would have no observable change or no visible change. To make this reaction visible, you would need to add an indicator. Let's try a second example. Sulfuric acid is with sodium potassium hydroxide. Now sulfuric acid is H2SO4, remember, which is aqueous. Now potassium hydroxide is an ionic compound. They haven't told us it's in solution, so that means it is a solid. Now once again, water is made from the hydrogen ions and the hydroxide ions. Don't worry about balancing just yet. The salt is made from the potassium and the sulfate. Now you have to follow correct ionic procedure. Potassium ions are +1 and sulfate ions are -2. So just go potassium sulfate K2SO4. Now this reaction is going to require some balancing. So balance the metals first. 1 potassium here, 2 here. So I'm going to put a 2 in front. Balance the polyatomic 1 sulfate, 1 sulfate. Balance hydrogens before oxygens. 2 hydrogens plus 2 hydrogens is 4. 2 times 2 is 4. Balance your oxygens. Don't include the sulfate, we've already taken care of it. 2 oxygens, 2 oxygens. Now we need to check out our state symbols. So potassium hydroxide, potassium sulfate, I'll go to sulfates. All sulfates are in the most soluble table, so most sulfates are soluble, except for these, which isn't this. So this is aqueous, and water is a liquid. Now if we want to check out the observations, we go here. So we're looking for what? Potassium hydroxide, which was a solid. I'm checking down my coloured ions. I start with my colours of selected solids, which is not on it, and then my coloured ions. So this is a white solid, and potassium sulfate is a colourless solution. Now we can do observations. This is a colourless solution. This is a white solid, a colourless solution, and a colourless liquid. So our observations here would be the white solid dissolves or disappears. To give a colourless solution. Let's try a third example. This time we have phosphoric acid, which is in solution, and we have barium hydroxide, which we've been told is in solution. Now the first part is to make our water, and the water comes from the hydrogen ions and the hydroxide ions. Do not worry about balancing just yet, just write the correct formula for water. And the next part is our salt. So our salt comes from the phosphate and the barium. Now correct ionic procedure is to write the positive ion before the negative ion, so it's going to be barium phosphate. Barium ions are 2+, and phosphate ions are 3-. So barium ions being 2 plus, phosphate ions being 3 negative. Common number is 6, so Ba3PO4 2. Now we need to balance. So we have balance for the metals first. We have 3 bariums here and 3 there. Balance for the polyatomic, we have 2 phosphates here, so we put a 2 over here. Balance for hydrogens next, we've got 2 times 3 is 6, add 3 times 2 is 6, so 6 plus 6 is 12, so 6 here. Balance for oxygens, 3 times 2 is 6, 6 is balanced. Now we need to actually work out our state symbols. So we look at phosphates, and phosphates are in the insoluble in water table, and most phosphates are insoluble. So this is a solid and water is a liquid. Checking the colours. Well, we had barium hydroxide solution. And I'm looking at my coloured ions in aqueous solution and find it's colourless. And we had a barium phosphate solid. Checking in number 1 here, there's no barium ions, barium phosphate here, so then we go to here and we find it must be a white solid. So my observations, this is a colourless solution, this is a colourless solution, this is a white solid, and this is a colourless liquid. So my overall observation would be 2 colourless solutions give a white precipitate. It's now time for you to try some yourself.